This script trains an autoencoder model on the FashionMNIST dataset using PyTorch Lightning. The model consists of an encoder and decoder, where the encoder compresses the input image into two-dimensional latent representation, and the decoder reconstructs the original image from this latent space. This project demonstrates the concepts of a dimensionality reduction, unsupervised learning, and model training with the early stopping, eventually leading to image compression. So the code contains data processing, model definition, training, and visualization. And these are the key concepts that are represented. And then it is a Jupyter based, so in the backend PyTorch, you should use any accelerator behind. In my case, I used NPS backend. So let me go over to the code. It's in the GitHub as well. So these are the library that needs to be installed. And initially, I use Torch Vision library to load the FashionMNIST dataset, and it just normalizes to -0.5 to +0.5, which I found more. It works a little better instead of -1 to 1. And then the train dataset converts to data loader, and it returns both train and tested dataset here. And then I use batch size of 256. And this is the main class, the autoencoder. So the autoencoder gets the 28 by 28 input, one hidden layer, 128, and then the liquid value of 0.01, and then eventually converts into two vector form here. The decoder is just the opposite, where it reconstructs an original image out of two vector representation. And this class is derived from Lightning module. So I just implement forward and training steps and optimizers. And I try to just display minimum, max, and just display few training samples to make sure the data has been transformed correctly here. So you can see -0.5 is black in this case, 0.5 is a white, and then the X-train shape is 256, which is the batch size, and that's 20 by 20, which looks correct. Okay, so after training, there's a visualization code here. And so let's look at the visualization. So it chooses random 8 images, and then that's the original training image or test image, and then I display a 2 vector. It's a 2-dimensional vector. That's the encoded vector. And then out of this one, try to reconstruct, and then you can see it works quite well for many cases. And then I can rerun. Then it selects different images as well. So you can see most of them it works well, but still it's not perfect. Now the 4th row is just I try to flip to negative value. So 5.12 to -5.12, 50.11 to -50.11. So you can see just it's flipped to negative. I try to visualize what's in the other side of the axis, and then doesn't quite make sense yet, but you can see they are opposite. So shoes and maybe dress, they, they, the model learned that they are very different. Yeah. Okay. And then I can run one more time to get another random images here, so you can see some of these cases. This looks like a high hill, but it's not doing well. Probably it's even outside the range. So the 50 was the maximum X limit, but then this one happened to be 54, so it is outside. So anyway, most of them are within 50 to 50 range. Also in this case, the purse failed here. And then there's another visualization that I put. So starting one image, I try to vary the vector to see what kind of images I get. This is more like generative images. So I try to vary the second element by 3, and by row it just increments the first value by 3 or so. So you can see these shoes, it varies. And then I can change where to something like maybe 10 and see. Then you can see the variation. But you can, yeah. So what I learned from it is that, wow, the sort of blouse, I mean the images, they tend to overlap each other, and then eventually it gets the final image. So I think it really helps to understand the vector representation. And I just do one more. I can do maybe 20, and then run it. Oh, maybe it's a similar file. Maybe 50, and then run it. Yeah, it looks like it's almost the same. So if I do like 200, yeah, and I get some pans, and then you can notice the slow transition of the image. Basically, this is the nearest neighbor visualization. So by doing this, it's much easier to what the encoded unsupervised learning is doing in the behind. Thanks for watching my presentation.